The diagram shows hexagon ABCDEF. AB, EF and CB, ED are congruent parallelograms where AB is equal to BC is equal to X. P is a point on AF. P is a point on AF. And Q is a point on CD such that BP and BQ is 10. So if I join a line from B to P and B to Q, they both are same. It means that triangle, if I make that triangle, it will be an isosceles triangle. Okay, if needed, we will use it later. Given that ABC is 30 degree, prove that cos PBQ is this, where what is X? AB is equal to BC is equal to X. Fine. Okay, so what we have to do in this question, we will break it off into two parts. First, we will be dealing with triangle ABC. Okay, all of you just see to it carefully. It is a good question. And there has to be a proper process we have to follow for solving such questions. Just look at triangle ABC, which I have taken from the figure. This is X, this is X. Angle ABC is 30 degree. So using this much data, we can get the value of AC. Now, before I proceed with calculation, I'll just show you why am I searching for AC. AC and PQ, they are same. You can see that they are same. So we can actually get the value of PQ by AC only. So that is my target. That is the reason I'm trying to find AC. Now for finding AC, we can use cosine rule. Okay, as per that, it will be AC square is equal to x square plus x square minus 2xx cos 30. 2x square minus 2x square cos 30 is root 3 by 2. So finally, it will be 2 minus root 3 times x square is equal to AC square. Right now, I will not be doing anything to this because maybe possible in our next step, we have to use PQ square. So AC square will be same as PQ square. That is the only thing you should know. And let us move forward from here. Now our next target will be, we will be discussing about triangle PBQ. So as per the figure, we can see that AC is equal to PQ. So AC square will also be equal to PQ square. So whatever value of AC square we have got over here, we will use the same value for PQ square in our further calculations. Now in further calculation, we are moving ahead with triangle PBQ. Look at the figure carefully. PBQ is what we are looking at now. So I'll draw the triangle. It is always a good practice to draw small figures, whatever we are dealing with. So this is PBQ. They're trying to ask, like they're asking us to prove this thing, okay, which has PBQ. This is Q. And then BP and BQ are given to us as 10. And this PQ will be taken same as AC. Okay. So let's say this cos PBQ for now it is theta. So I can write it down as cos square theta. Remember this time I'm using which formula? I'm using cos theta is equal to a square plus b square minus c square over 2ab. We have two formulas for cosine rule and anything can be used as per the requirement. So now it will be cos theta is equal to 10 square plus 10 square minus pq square over 2 times 10 times 10. The value of pq square, as I was saying, that we may not have to do anything. We will just use this value directly in place of pq square. So now what do I have? 100 plus 100, 200 minus pq square. Pq square is 2 minus root 3 x square. And in the denominator, we have 200. That 200 can be divided individually for both the numerators. And that is equal to cos p bq. Finally, 200 by 200 will be 1. So cos p bq is equal to 1 minus 2 minus root 3 over 200 in the bracket together times x square. Why we are not doing anything to it? Because this is the form what they have asked us to prove. We are done. So in this question, we are actually trying to prove this formula for area of triangle. Okay. Now to begin with, it is expected that at this level, all of you should know that area of triangle is half base times height. This is a fundamental formula which we are using from lower grades. Okay, so it is up to us whichever angle we will choose, but they're asking us to prove AB sine C. AB sine C means we are going to choose angle C. So what you will do now, from point A, you will drop down a perpendicular. And that perpendicular is like an altitude of a triangle. We can name it as H. and this angle is C. Okay, so just focus on this triangle for now. And with respect to this triangle, just let me know if this is clear or not. I can write sine C is equal to h over b. H is the opposite and b is the hypotenuse. So the value of h can be written as b sine C. I will just apply area of a triangle, the conventional formula what we have done earlier, that is half base into height. Base is a, height is b sine C, and that is how area of triangle is proved as half ab sine C.